All right, the start of the second unit called Roots and Powers. We're going to start with a number system, which it should be familiar to you. I know you've seen this before. Maybe you didn't take it too seriously, didn't think too much about it. But basically, we're talking about grouping numbers into sets. Okay. What you need to know this year is there's what we call real numbers. Real numbers, basically, they're any number you can think of. In fact, if you take a number line, all right, and you randomly point to a spot on the number line. So if you point to a spot on the number line, that will be a real number. You know, for example, if this is 0 and this is 1 and this is 2, this number is something between 1 and 2. Maybe it's 1.2, maybe it's 4/3, but it's what we call a real number. The numbers that are not real, you don't have to worry about. Okay, there's what we call imaginary numbers. There are complex numbers. There are many types of numbers that you might deal with if you take math in university, but you don't have to worry about those. Just for your own interest, the imaginary number is the root of -1, which is represented by a small I like that. Okay, but we won't touch that. We won't deal with that. You don't have to worry about that. Okay, we're dealing with real numbers, numbers that will go on a number line. And so what do these sets look like? Well, the first, and, well, I can't say smallest set, is the natural numbers. Okay, the natural numbers are just counting numbers. 1, 2, 3, 4, 5, 6, 7. No negatives, no decimals, no fractions, nothing. Okay? A slightly larger set is the whole numbers, and all it has extra is a 0. And you think, well, that means it has one more element in the set. But the reality is they both have an infinite number in their set, and so the size is the same. That's weird. Hard to get our head around that. Don't worry about that. Okay? The next group, integers, and by the way, you can see that the natural numbers fits inside the whole numbers, which all fit inside the integers. Okay, so if it's a natural number, it's also a whole number, it's also an integer. An integer is just the natural numbers and their opposites. Okay? The next set would be the rational numbers. The rational number starts to include things that don't go, they're not whole numbers, not a 1 or a -1, but what goes in between a 1 and a 2. Okay, it could be a decimal, could be a fraction. All right? And then outside the rational numbers is the irrational numbers. Now, what's the difference between these two? The only difference is that a rational number can be written as a fraction, whereas an irrational number cannot be. Okay, and that's a little bit hard to get our head around. You know, how do we know if it can be a fraction or not? Well, let's do a little bit of practice with that. Okay, here are some numbers. And let's say, which number system does each number belong? The 0. So where is the 0? It's right here. What number set does that belong to? Well, it belongs to the whole numbers. But because it belongs to the whole numbers, and that whole number set is inside the integers, 0 is also an integer, which means it's also rational. Okay, and if you remember, the symbol for rational is Q. And because it's a number in here, in this box, it's also a real number. Now, I don't need you to write the symbol for real numbers because we're only dealing with real numbers, so all of these are real numbers. Okay, keep that in mind. They are all real numbers. All right, so I don't need you to write that. The real numbers are, we put 2 lines like that with an R. Okay, these are all real numbers. So next one, 3.2. Okay. Is 3.2 a counting number? No. Is it a whole number? No. Is it an integer? No, because it's not a whole number. It's not. It has a fraction in it. 3.2, part of a number. So this is what we call a rational number. Okay. Same with 5/2. 5/2 is a fraction. By definition, a rational number is any number you can write as a fraction. So if you see a fraction, it's a rational number. Okay. Root 16, this actually equals 4. That means it's a natural number. That means it's a whole number. That means it's an integer, and that means it's also rational. Okay, now root 2. If you put root 2 in your calculator, you're going to get a decimal. And that decimal goes on forever. Okay, so this is going to be an irrational number. An irrational number is a decimal. It's infinite, so it goes on forever. Okay, but it does not repeat. Alright, so as an example, decimal 333. This is a decimal that goes on forever, but it repeats. This is not an irrational number. In fact, this can be written as 1/3. That's why it's rational. Okay, whereas a decimal like 121121112 going on forever, this repeats, it goes infinite, but there's no section of it that repeats. Now you can see a pattern in there, but you can't take one section and say this is repeating over and over again. Okay, so root 2, this is going to be an irrational number. Whereas decimal 777, it ends, it's finite. That means I could write this as 777 over 1,000. So since I can write it as a fraction, it's rational. Okay, so that's the difference between rational and irrational. 8, this is a natural number, which means it's whole, which means it's an integer, which means it's rational. -2, I see the negative. This is an integer and also rational. And here I see the negative and I think, oh, it's an integer. But wait, integers are only whole numbers, not decimals. So this is just rational. Okay? So, I mean, don't stress about that. We're trying to get a feel for where the numbers belong. I don't expect you to be perfect with that, but I will ask you that on a test. I will give you some numbers and say which set does it belong. Okay? So why do we need to know that? Well, part of it's to be able to look at a number and decide, is it rational or irrational? Can I have an idea how big this number is, and do I understand what it represents? Okay? So, the question here says, with a partner, determine which of these radicals are rational and which are not. And the big question is, how do you know? Well, it will be great if you could have your calculator, but this unit, you cannot use your calculator. So you need to be able to do this without a calculator. You need to be able to look at these numbers and say, are they rational or not? Okay, well, let's look at 144. If you recognize 144, you know that that's 12 squared. Okay, well, what would 1.44 be? Does it make sense to you that that's 1.2 squared? So the root of 1.44 is actually 1.2. That means it's a rational number. Okay? This next one, the root of 64 over 81. I hope you recognize that both of those are perfect squares. The root of 64 is 8, and the root of 81 is 9. This is a fraction. That means it's rational. Okay? The next one, the cube root of 27. Well, this is -3, because -3 cubed, -3 times -3 times -3, is -27. That's an integer, which means it's also rational. The next one, well, the root of 4 is 2, but the root of 5 you can't do. Well, you can if you had a calculator. It's going to give you a decimal that repeats itself. And why do I know that I can't find the root of 5? Well, I know the root of 4 is 2, and I know the root of 9 is 3. Root 5 is somewhere in the middle of that. This tells me it's an irrational number. All right, so this one is also going to be irrational. Okay. Okay, let's finish this fill in the blanks here. Radicals that are roots or maybe I should put square roots of perfect squares cube roots of perfect cubes, and so on, are rational. So if we can take the square root of a number, if we can take the cube root of a number, they're going to be rational. Okay, rationals have decimal representations that either terminate or repeat. Okay, so let's take a look at a couple more examples. Tell whether each number is rational or irrational. Explain how you know. This first one, this is rational. Why? It's a fraction. All fractions are rational. The next one, the root of 36 is 6. Why is it rational? In fact, it's more than rational. It's a whole number. It's a natural number. It's an integer. Okay, how do I know it's rational? Well, it can be represented as a fraction. How can 6 be represented as a fraction? You could write it as 6 over 1. Okay, remember, what is rational? A number that can be written as a fraction. Okay, next one, cube root of 8, that's 2. The cube root of 27, that's 3. This is rational. Why? Because it's a fraction. And root 14, I don't know what that is. I know it's bigger than root 9 and it's smaller than root 4. So this is going to be 3 point something. I'm just not sure what. That means it's irrational. Okay, y cannot be written as a fraction because that decimal does not terminate and it does not repeat. Okay, next example. Use the number line to order these numbers from least to greatest. So here's what we're going to do. We're going to put 0 there. And we're going to put these numbers somewhere on the number line. Okay, take a look at those. Do you know any of them easily? Well, I think root 9 is 3. That would be an easy one to put on the number line. Here's 3, so let's put root 9 there. Excuse me. Do you know any other ones easily? I don't think so. Okay, so let's try and look at the next one. Let's look at root 18. That one looks like it's maybe easier of the other ones. What is root 18? Well, I know that root 16 is 4, and I know that root 25 is 5. Root 18 is somewhere in between 4 and 5. So let's put that here somewhere. There's 4, there's 5. I'm going to put root 18. Now, where do you think it should be? Closer to 4 or closer to 5? I think it's going to be somewhere around here. Okay, again, we're just ordering them. It doesn't have to be exactly correct. Okay, so we've done those two. Which one do you want to do next? Well, let's do the cube root of 13. Well, I know the cube root of 8 is 2, and I know the cube root, well, what's the next one? What equals 3? It's the cube root of 27. The cube root of 13 should be somewhere between 2 and 3. I think closer to 2. So I'm going to put it right about here. Okay, that's somewhere between 2 and 3. Okay, why don't you guys try a few of these? Can you try the 4th root of 27? So we're trying to think what's above and what's below. Well, what equals 2? That would be the 4th root of 16. What equals 3? That would be the 4th root of 81, because 3 to the power 4 is 81. So 27 is also between 2 and 3. Uh-oh. Do you think it's bigger or smaller than the cube root of 13? This is a tough one.